All right, back to it. 32. Use a right triangle to write the expression as an algebraic expression. Assume that x is positive and in the domain of the given inverse trig function. These are always done in quadrant 1. Always done in quadrant 1. View that as x over 1 so you can use opposite over adjacent. I understand this is arctangent. This says what is the sine ratio of an angle whose tangent ratio is x over 1. That's all it says. Anyways, just assume you're in quadrant 1. These always are. Because quadrant 1 is within the domain of arctangent. The tangent ratio is opposite over adjacent. By the way, you'd be right here. That's where your angle would be. And you do a little Pythagorean theorem to find the hypotenuse. C squared is x squared plus 1 squared. So C is the root of x squared plus 1, which you can't do anything with. There's your little triangle. Now you want the sine ratio. The sine of any angle is opposite over hypotenuse, always has been, x over that. Probably don't clean that up. You might, but you probably don't. I don't know what the key do. I don't think it should be cleaned up. They did clean it up. That's kind of surprising. So if you clean it up, you just multiply by the root of x squared plus 1. This would be x times the root of x squared plus 1. And the bottom, a radical times itself, is the contents inside. All right, use transformations to graph the function y equals 2 cosines of a half x plus 2. Your normal period is 2 pi. We have a half there. It's been a minute since I've done this, and you guys were taught using, I think, b. So your period b here, or sorry, your period here on this one, p, is going to be 2 pi over b. And they have a half there. 2 pi over half is 4 pi. So it takes 4 pi to complete the wave. Hold on, I'm recording. Give me a sec. And I got to get interrupted. And I'm back. Let's see, where was I? Oh yeah, I found our new period. This is your shift up. And this is your amplitude. Now, when you think about y equals cosine of x with no modification, cosine of 0 is 1. So we kind of start high and then we work our way low. Right? So this one's going to start at 2. And notice it has a full period of 4 pi. And this thing only goes out to 2 pi. We're not going to be able to kind of do things like we normally do here. We're only going to be able to draw half of it. We have shifted up 2 because we're cosine. We have to start high and then we have to fall. This would normally be on a graph of pi. It's going to happen at 2 pi, if I'm thinking right. Yeah. Yeah, it would be that side. You're really only going to get a bell curve out of this thing. That's about it. I'm really messing this up. It's not a bell curve. It's supposed to keep on falling. I've messed it up. It's supposed to kind of do this and curve back up. Shifts always mess with my head too. This was supposed to be the inflection point. So that's all you see is the stuff in the middle. Alright, use the given information to find the exact course on your test. It would be multiple choice. Wouldn't be too bad. Use the given information to find the exact value of the expression Sine of theta is 15/17. Theta lies in quadrant 1. Find the cosine of twice theta. So I guess you just need a formula. So I should probably pull up a formula, because you have this one. And somewhere I have it saved. There it is. We were asking for the cosine of twice theta. And this is the one they give you right here. That's the one we'll use. So I just wrote it down. Now they tell me the angle lies in quadrant 1, so I'm going to draw myself a little triangle in quadrant 1. Sine ratio is opposite over hypotenuse. Now your missing side here, I'll just call it x. X squared plus 15 squared is 17 squared. 15 squared is 225. 17 squared is 289. And 225 minus 289 ought to be 64. So x squared is 64 and x is 8. The old 8, 15, 17. Seems right. I'm going with it. Now the reason I did this is because of the stuff I need over here. In addition to knowing the sine ratio, I need to know the cosine ratio. So from my little triangle here, the cosine ratio is 8/17. Now you can just plug stuff in. The cosine of twice theta would be an 8/17 that is squared. Take away a 15/17 that is squared. Now, the reason this is going to come up negative is because when you talk about twice the angle, it's going to rotate into quadrant 2. So don't be alarmed by that. We're going to have 64 over 289 minus 225 over 289. And what's the difference there? 136 and 25, I think. 166, 161. Negative 161 over 289, if I'm thinking right. Yeah, I think I'm thinking right. There you go. Find all solutions of the equation. 2 cosines of x minus 1 is 0. Do the easy stuff. 2 cosines of x is 1. Cosine of x is a half. Now, they say all solutions. They're probably wanting you to write out something like through repetition. So you need to be thinking about where on the unit circle cosine is a half. There's 2 places. It's in quadrant 1 and quadrant 4. One of them should be a 60-degree angle. I think on a pi over 3, I think you're looking at what, 1/2 root 3 over 2. So from unit circle, I believe I'm thinking something along the lines of pi over 3, and presumably 4 pi over 3, 5 pi over 3, 5 pi over 3. And there's a pattern here. It turns out that pi over 3 plus pi, nope, that's not right. 4 pi over 3 is the other one. Pi over 3 plus pi is 4 pi over 3. So the pattern here is pi over 3 plus k pi, where k is an integer. All right, solve this one on the interval from 0 to 2 pi. Cosine of x plus 2 cosines of x sine of x is 0. This one looks like it's factorable. I'm going to pull a cosine of x from both pieces. That'll leave me with 1 plus 2 sines of x being 0. And then I get to use my zero product property. The cosine of x is 0, or 1 plus 2 sines of x is 0. Now, where is the cosine ratio 0? That is at what, pi over 2 and 3 pi over 2? There's two answers. You know, this one is going to end up being sine of x equals negative 1/2. So where is the sine ratio negative 1/2? That's going to be down in quadrants 3 and 4. 7 pi over 6, and what else? 11 pi over 6. You know, I know you couldn't see what I was doing there, but I was visualizing the unit circle. And it's bright and early, so I had to close my eyes when I did it. I feel like that's right. I'm going with it. Another one of these with some trig here. 2 cosine squared is x plus sine x minus 2 is 0. I feel like this should be rewritten using sine squared plus cosine squared is 1. I want nothing but sine so that I can factor. So I can replace cosine squared with 1 minus sine squared. And I can distribute here. And I'm going to have 2 minus 2, which is none. So I'm going to have a negative 2 sine squareds of x plus sine of x being 0. And that is factorable. That is factorable. There's no doubt about it. I can pull out a sine of x. If I pull out a sine of x, I'd have negative 2 sines of x plus 1 being 0. So I end up here with a sine of x being 0, or negative 2 sines of x plus 1 being 0. Oh, I got small there. I'm sorry. I'm trying to not use other pieces of paper here. The sine ratio is 0 on the unit circle at what? 0 pi and pi? Seems right. So there's two answers. This little guy right here, if we solved it for sine, would be that the sine of x is a half. Everything's said and done. And that is at pi over 6 and 5 pi over 6. Assuming my brain's working right. I feel like it is. All right. Polar coordinates are given. Find the rectangular coordinates of this point. So x is the radius times the cosine of the angle, and y is the radius times the sine of the angle. That's how hard this problem actually is. So x is negative 7 times the cosine of 120 degrees, and y is negative 7 times the sine of 120 degrees. So I'm at a 120 degree angle, and I'm just going to think about the unit circle here. Maybe. The x value is a negative 1/2, isn't it? Makes sense. So x is negative 7 times negative 1/2, which is 7/2. And if I'm at the unit circle at 120 degree angle, seems like the sine ratio is root 3 over 2. So this one right here is negative 7 times root 3 over 2, which is negative 7 root 3 over 2. So you got your x and you got your y. All right, 39 is going the other way around. The rectangular coordinates are given. Find the polar coordinates. Express theta in radians. Kind of a big deal there. I actually like to draw these because it lets you know what quadrant you're in. Now these will be something that you don't have to use a calculator on, but to get to this point, I would go right 5 root 3 and up 5. And you should catch on real quick that this is a 30, 60, 90. Sweet. You don't even have to use a formula on this one. The hypotenuse has got to be 10. So my radius is 10, And my angle here, 30 degrees, is pi over 6. So 10 pi over 6 is my answer as a polar coordinate. See, we don't do partial decomposition. Here's something old. A vendor sells hot dogs and bags of potato chips. The customer buys 5 hot dogs and 4 bags of potato chips for $15.50. This is straight up Algebra 1. 5 hot dogs plus 4 chips is $15.50. Another customer buys 2 hot dogs, and 5 bags of chips for $8.75. Straight up elimination. What's easier to go after? I don't know. Probably hot dogs. 5U and 2U. So 10 hot dogs plus 8 chips is now $31. And 10 hot dogs plus 10 chips, 25 chips. Give me a minute, I'm recording. Let's see. Oh, I hate interruptions. 5 times 8 is 40. We got 375. 43.75. And we'll just subtract down and see what we get. We subtract down, we have negative 13 chips equals, what, negative 12.75? And I guess I'll go see who's at my door, and I'll come back to this in a second.